The third part is a part of real-time statistics. For the part of real-time statistics, you can see a display in the chart below. Actually, we are considering, because every worker node or master node implementation of its mandate distribution at each moment it is actually not very clear. Therefore, we consider whether we can make a real-time statistics and display. So we use stats plus influx and graphna then to do an overall strengthening transformation. This technology stack mainly uses Stat's microservice statistics architecture. It is an open source component. And then mainly using timing, and then container, and then its collection is a cities, and then. The price is this word is mainly an interface of API that we call it, then go and embed into our master worker service. Because every time we run, we will do a real-time statistics through our master or worker service. Then send it to our Flash DB regularly. And then we graph and then we go to visit our Flash DB, then finally API calls our graph. Then make a presentation in front. The following figure is the part we show. Then through it, we can intuitively see, master or worker. Of course, we are showing the worker department now. Every moment of his task runs a situation. That follow-up is also convenient for us to see. Every worker ends up running a load situation of the task. There may be a sharp increase, there may be a possible decline. Therefore, it is convenient for us to set up task groups later, when grouping can be able to balance a load situation of a certain group of servers. Finally, in fact, this piece has a small expansion, that is to say, in fact, our framework system goes to further count its memory and the report of CPU to our infrastructure. Later, we can count the statistics of its memory and CPU, I/O, or reading and writing or I/O reading and writing statistics. You can push, then make a certain recommendation, some recommendations of a certain server. And then for the user to choose. In the course of a mission. This is this part. And then, it may be strengthened. There's another one timing offline modulium, regularly goes offline or goes online. Because we still have a lot of servers, it's about 80 sets. Because every time we have to do functional transformation or task upgrade, it can't be maintained manually, a script is required to do the distribution and execution as a whole. Therefore, we consider whether we can have a unified interface to manage all these. So we transform the master management and worker management in a unified way, namely, offline upgrading. That's mainly, master and worker. We are mainly adopting an updated mechanism. The updated mechanism actually contains offline, refresh, restart, and rollback if there is a problem. The main part is our downtime part. Then downtime specifically, how did it come true? Because our downline is dependent on Zookeeper, because we're in these active servers. In fact, we maintain addresses in Zookeeper. We can use Zookeeper to get our online list of servers. And then if we go offline, or when the user marks that he wants to go offline, we need to get master in the offline server marked. Then compare the server that has been offline with the server that has not been offline, then we can get this list of our offline by comparing it. Then the servers of the offline list are subsequently upgraded and restarted. The general logic is like this. And then if it's just a little update, it will perform our tags and go offline, then determine the number of jobs running on this server, is it or not. 0. Because as long as there is a mission, it is not allowed to go offline under operation. If it is marked as going offline, its state will change. Therefore, it is necessary to record a corresponding status information, including the current version upgrade information.